Hi. In your previous calculus lectures, you probably encountered a lot of different surfaces in our tree. For example, a cylinder, a sphere, or a paraboloid, like the one that is about to appear on the screen behind me. All of these surfaces can be described by a so-called Cartesian equation, an equation in x, y, and z that determines which points are on the surface. For the paraboloid on the screen, the Cartesian equation is z equals x squared plus y squared. Now, sometimes it can be a bit more convenient to work with a parametric equation of a given surface. This means that we will try to write the coordinates of the points of our surface as functions of certain parameters. In the upcoming lectures, you will see how you can compute the area of a given surface and how you can integrate a function over a certain surface. Now, in all of these cases, you will need a parametric representation of the surface that you are working with. You already used parametric equations to describe curves. A simple example of a curve in the plane that can be described by a parametric equation is a circle centered at the origin with radius 2. Each point on this circle has a position vector r. The x-coordinate of this vector is equal to 2 times the cosine of theta, and the y-coordinate is 2 times the sine of theta, where theta is the angle between the vector r and the positive x-axis. The vector 2 times cosine theta, 2 times sine theta is a parametric representation of the circle. For each value of theta between 0 and 2 times pi, you obtain a point on the circle. Now let's get back to our paraboloid. The paraboloid is a surface. It is two-dimensional. This means that a parametric representation will contain 2 different parameters. In fact, there are various ways to give a parametric representation of this surface. Let's start with the most obvious one. Okay, take an arbitrary point on the paraboloid. Since we are working with the graph of a function, this point is determined by 2 parameters. In particular, its x and its y coordinate. The z coordinate is by definition equal to x squared plus y squared. This means that the vector with coordinates x, y, and x squared plus y squared is a parametric representation of the paraboloid with parameters x and y. Let's take a look at another way to describe this surface. Once more, we take an arbitrary point on the paraboloid. Our first parameter will now be the z-coordinate. All the points on the paraboloid with that same z-coordinate form a circle. And if we project this circle onto the xy plane, we get a circle with the equation x squared plus y squared equals z. This is in fact a circle with radius equal to the square root of z. Each point on that circle has an x-coordinate equal to the square root of z times the cosine of theta, and a y-coordinate equal to the square root of z times the sine of theta, where theta is again the angle between the position vector and the positive x-axis. This gives us a second parametric representation, where the parameter theta is an angle between 0 and 2 pi, and z is a positive number. That's all for now. I hope you enjoyed this video, I hope you learned something, and I'll see you in class.